folks, it is I, Mr. Geary, your geometry teacher, and I am not here today, as if you couldn't tell that already. Back there in the back of the room is your substitute teacher, and I want you to treat him or her very well today because they're here doing a very important job, basically keeping you from killing each other, okay? Today, we've got an important lesson that we're still going to do even though I'm not here. It's not particularly difficult, but it does take a little bit of explaining, and I want you to understand it fully so that you can do the work that goes along with it and be prepared for all the fabulous work that we've got ahead of us. What we're talking about today is what's called reasoning. I mentioned it before. Chapter 2, it's right over here on this wall. Chapter 2 is reasoning and proof. Reasoning is what geniuses do to figure stuff out, but not just geniuses. Normal people reason every day. Reasoning is how you figure stuff out. Take a look over there on that wall. It's my word wall word for the week. I mentioned it a couple of days ago. Reasoning is thinking, understanding, and forming judgments using a process of logic. It's figuring out stuff, okay? That's not that difficult, but there are different ways that we do it. And what we're going to do today is we're going to figure out those couple of different ways we do it, some specific reasoning strategies that we use, and then we're going to practice using those looking at patterns of things. It's going to be fun, trust me.
So, who are these geniuses I'm talking about? Well, there's Isaac Newton. He was asked one time, hey, I see those planets spinning up there in the sky. Can you predict how those things move? He says, well, let me get back to you. He goes off, comes back, and he's invented calculus. The guy basically created math as we know it. Then he turned 26. We've also got René Descartes. He's considered the father of analytical geometry, the class you're in now. There's Einstein. Nobody disputes that he was some kind of genius. What he called his reasoning was thought experiments. It's where he said, hey, I wonder how this works. Then we've got, this guy's Leonhard Euler. We'll learn about him later.
By now you're probably asking the question, what is reasoning? What is this sort of thinking about things that Mr. Geary is talking about? Well, here, let me show you a couple of examples. So, I've got this homemade air-powered rocket launcher. I'm going to shoot it off straight up into the air. I wonder if it's going to come down and hit me in the head. Is figure out how those parts relate to each other. Put them together in that relationship. Make a relationship.
I bet just this once, if I explain it to them real carefully, they'll all understand it on the very first try. Yeah.
Find out what your x is, and then use that x to find the original.
So what do you think? Is it going in? So what am I getting at with all these examples? Only this. In every one of them, you saw what was happening and you made a prediction in your mind, whether you wanted to or not, about what was going to happen in the future. What you made, we call it in math, is a conjecture. A conjecture is simply a prediction about what's going to happen in the future based on what happened in the past. And when you do that, when you make a conjecture about something, a prediction, you're using a special kind of reasoning we call inductive reasoning. It's one of the two. There's inductive and deductive reasoning. Inductive reasoning is when you look at what happened before, predict what's going to happen in the future, and make a conjecture about what that future will be. We're almost through. There's just one more little detail. When you saw what the past looked like, you made your prediction about what the future was going to be. But what happens if, even once, something happens that doesn't fit with that prediction of the future? Take my basketball example from before. You watched me make basket after basket after basket, and I asked you what was going to happen next. Your guess is most likely that I'm going to make the next basket. Maybe I'm perfect, but eventually I've got to miss one, don't I? At that point, your prediction breaks down, and your conjecture proves to not necessarily be true. Let me give you maybe a little bit deeper example that may make it a little make more sense. Imagine if you have fires at your house. What happens? You call the fire department, and every time the fire department comes out to put the fire out at your house. But what happens if even just once the fire department doesn't show up? What are you going to think about the fire department's reliability and whether or not they're actually going to come out the next time you have a fire? Even just one example that proves your conjecture false is called a counterexample. And that one counterexample is plenty to make your conjecture come out false and your inductive reasoning basically not work. So that's about it. Inductive reasoning is the kind of thinking you do when you use what happened in the past to predict or make a conjecture about what's going to happen in the future. And if even once something happens to disprove your conjecture, it's called a counterexample, and it basically breaks the whole reasoning apart. Basically what you do is you find patterns in the world and you predict what the pattern's going to do in the future. That's what I'm going to have you practice on now. Your substitute's going to give you this sheet. It's got patterns on it. You start with, say, 3 dots, and then 6 dots, and then however many dots that is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many dots are going to be in the next pattern? And what's it going to look like? I want you to sketch the next one in the pattern for all of these down the front of the page. Then on the back of the page, there's some more patterns, but this time they're numbers instead of shapes. Look at the numbers, see what it is that happens to the number from one number to the next, and then predict what the number is going to do in the future. Then, on the bottom of the page, it's your turn. I want you to make some patterns. I want you to draw shapes. They can be like these. They can be other shapes. They can be pictures for all I care. I just want you to come up with your own pattern that changes predictably from one space to the next. And then, this is the neat thing, I want you to hand your paper off to a partner. They're going to put their name on your paper, and they're going to see if they can predict what happens in the future from your pattern. I hope you enjoy it. Have a good day.